So NVIDIA just dropped a bombshell announcement, and it might just be the key to unlocking the next massive leap in computing. They think they finally figured out how to tame the wild, chaotic power of quantum computers by teaming them up with the undisputed workhorse of AI, the GPU. Let's dig in and break down what this really means. Okay, so to really get why this is such a huge deal, we first have to talk about the fundamental problem at the very heart of quantum computing. You see, it's this incredible, beautiful genius that's also just incredibly unstable. The source of all this magic is something called a qubit. Now, unlike a regular computer bit that's just a 0 or a 1, a qubit can be both at the same time. And that's what gives quantum computers their mind-bending power. But, and this is a huge but, here's the catch. As powerful as they are, they're also super delicate and error-prone. And honestly, that fragility, that's been the single biggest roadblock stopping us from building truly useful, large-scale quantum machines. And that, right there, that is the question. It's the multi-billion-dollar problem that scientists and engineers all over the globe are racing to solve. How in the world do you harness that unbelievable power without the whole thing just collapsing into a mess of errors? How do you make that genius reliable? Well, NVIDIA just stepped up to the plate with what they believe is the answer. They're basically proposing a kind of Rosetta Stone to finally translate between the two completely different worlds of classical and quantum computing. Yeah, NVIDIA's CEO, Jensen Huang, he calls this new system the Rosetta Stone. And you know what? It's a perfect metaphor. It's all about letting two completely different languages, the stable, predictable language of GPUs and the wild, probabilistic language of quantum processors, finally talk to each other. And that Rosetta Stone, it has a name, NVQLink. At its core, it's an open architecture designed to create this incredibly fast bridge between the GPU supercomputers we already have and the quantum processors, or QPUs, that are on the horizon. It's like the physical and digital handshake that's been missing all this time. So let's get into the nitty-gritty. How does this connection actually work? And why is pairing these two seemingly opposite technologies so transformative? This really lays out why they're a perfect match. Think about it. On one side, you've got the GPU supercomputers. They're orderly, they're stable, they are the absolute masters of doing thousands of things at once. Their whole design, which was perfected for AI, makes them ideal for running tons of complex control algorithms. And on the other side, you've got the quantum processor, this storm of immense, chaotic power. It's unbelievably fast, but it needs a steady, guiding hand to keep it on track. So here's how it all comes together in basically 4 steps. First, you connect them. NVQLink is that flawless, super fast highway between the two. Then, the GPU takes control. It runs all the complex calibration stuff, keeping things in check. This is what enables the holy grail, real-time quantum error correction. It's constantly fixing those fragile qubits on the fly. And with that stability, the whole hybrid system can finally accelerate and start tackling these world-changing problems. But look, building a bridge like this, it's not a one-company job, not by a long shot. This is a massive, coordinated effort to create an entirely new computing ecosystem, basically from the ground up. And to build out this ecosystem, they've pulled together a huge coalition. I mean, right out of the gate, 17 different quantum hardware builders. These are the companies actually on the front lines making the QPUs. They've all joined the initiative. And if that wasn't enough momentum, get this. 9 U.S. national labs are also on board. We are talking about the institutions with the biggest supercomputers and some of the brightest minds on the planet, all working together to guide this thing. And these aren't just any labs. We are talking about the heavy hitters. You've got places like Oak Ridge National Laboratory, a world leader in supercomputing, plus Sandia and Brookhaven. Having them involved gives this project incredible credibility and, well, a ton of resources. This quote from the U.S. Secretary of Energy, Chris Wright, really puts the national importance of this into perspective. This is not just a cool science project. It's being framed as a strategic move to secure America's tech leadership on the world stage. So let's zoom out for a second and look at why this matters to, well, everyone. This isn't just about faster computers for scientists. This is about kicking off the next global computing race. The implications here are just massive. This could dramatically speed up finding solutions for huge challenges in chemistry, in drug discovery, It paves the way for quantum computing to finally move out of the research lab and into the real world for commercial use. It's absolutely a key move in the global technology race. But maybe the most important thing is that it creates a scalable path forward, a real roadmap to get from the hundreds of qubits we have today to the hundreds of thousands we're going to need for those truly world-changing calculations. So, we're left with the big question. After all these years of hype and frustration, does this finally mark the dawn of a practical quantum GPU era? It's impossible to say for sure, but this is without a doubt one of the most significant steps we've seen in that direction yet.